afternoon, ladies and gentlemen, and welcome to this session of this is Track 2B, Environmental Sciences Future Faith-Based Water Management presentations. My name is John Wood. I will be the moderator this afternoon. So we're going to begin this afternoon with the presentation that you see on the screen. And Edward Berkelaar is giving a presentation together with Darren Brower, and Darren is sitting in the back. Thank you. And both are professors at Redeemer University, which is in Hamilton, actually up on the escarpment, if you know where that's at, right here locally. Part of the Christian colleges and universities across Canada and the United States, and a four-year liberal arts institution. Edward, Darren is a professor of chemistry there, and Edward is going to be our speaker, I think, primarily today, yes. And Edward's, I just found out, got kicked upstairs, and he has been made the dean there at Redeemer, so congratulations, sir. And administration is one of the gifts of the Spirit, and so you've been both called and gifted. So, all right, so it's going to be a talk today on monitoring water quality of the Chedoke Creek Watershed, which I have heard a bit about before. This is a long-term project, and it's science for the public good.
Well, good afternoon, everyone. I get a chance to talk about the Chedoke Creek this afternoon, which is one of my favorite places in the world, so I'm looking forward to it. The outline today, I'm going to talk about the Chedoke Creek Watershed. It's a beautiful place, but deeply broken as well. And I'm going to talk about sort of its context, its relevance. It flows into a very significant wetland in Hamilton called Cootes Paradise. Cootes Paradise is connected with Hamilton Harbor, which is a Great Lakes area of concern that there's been an awful lot of work over the last couple decades trying to clean it up. And so part of that then is cleaning up the watersheds as well. And then I'll move on and talk about 10 years of water monitoring and then some project outcomes, what we've learned along the way and some relationships that we've made. So here's a picture looking south of part of Hamilton. The wetland that I mentioned, Cootes Paradise, is in the bottom right here. The highway runs through sort of it used to be a sandbar, but it's the highway now. And to the left is Hamilton Harbor. And this is kind of looking sort of southward over part, at least, of the city of Hamilton. And sort of outlined in yellow is the Chedoke Creek Watershed. Running right through the middle, sort of left to right, is the Niagara Escarpment. And so the majority of this watershed is buried under subdivisions that were built in the 1960s and 70s. But we have access to the water by hiking along the escarpment, which is quite pleasant, actually. And just to give you a sense of sort of, beauty and brokenness, there's some beautiful places. You're in the midst of sort of, this large urban area, and you step off of a trail, and there's beautiful sort of tributaries of the Chedoke Creek watershed that are scattered, over a several kilometer stretch, sort of east and west. And Hamilton, all cities have a history, but you can see maybe by looking at this map, the escarpment runs through here. There were train tracks built along the escarpment. Much of the southern part of Hamilton is farmland at this time. This is probably mid-1800s. The city is sort of concentrated down by Hamilton Harbor. And if you kind of zoom in on this area and blow it up, you can see the Chedoke Creek watershed. I've just sort of traced it in blue here. And the map is a little bit limited. There's sort of other tributaries to the west that were once there as well. And this is a map today. It's not, the word kind of shook me when I first learned it. We call this a sewer shed. Nothing is, at least on the mountain, nothing is sort of exposed. It's all buried in pipes. And this is a map we got from the city of Hamilton, which is quite fascinating to stare at for a while. I know you can't see it, but all of the purple lines have arrows on them, and they show the flow of stormwater. Those are all buried pipes. And if I, again, sort of pull up that old map, it may be faint for you, but if you sort of look to the right, there's sort of a yellow sort of traced pipe, and it's a huge one. That follows roughly the original path of the Chedoke Creek. And when the subdivisions got built, they dug a massive trench, they put in a huge pipe, and then buried everything and built right on top of it. And that, in some ways, is the end of the watershed as we knew it, I guess. But somewhere where it starts, there is a history of a significant spring. And there was a farm that was built around that spring because it was a constant source of very clean water. And this is what it looks like now. There's, if you look at the picture on the top right there, you kind of look up at the escarpment, and there's quite a significant pipe built into it. And I've not done it. I'm not interested in doing it, but people have crawled in these and taken wonderful pictures of this huge network underground that is sort of collecting this constant flow of water. And you would not want to be anywhere near in there if there's ever a rainfall, because those pipes fill enormously quickly from a huge volume of urbanized, hard surfaced area. And there's almost no opportunity for water to soak in anywhere. So here again is the map, and I'll go through this one quickly, but this is sort of a Google Maps view of Hamilton, and we have Hamilton Harbor here. We have our main sewage treatment plant, which deals with about 90% of the sewage of the city. And Hamilton, roughly 500,000 people, so it's quite a large scale. Our drinking water plant is there as well. The escarpment runs through the city, and there's Cootes Paradise, and here's the Chedoke Watershed, which flows. I know the map, my little sketch catches Hamilton Harbor too, but it does flow into Cootes Paradise. And I'll just quickly point, our sample sites kind of just sort of follow the escarpment right through the middle of, most of the sample sites, right through the middle of the Chedoke watershed. So Cootes Paradise, again, beginning in the 1980s, started to receive a lot of attention. And this is, it's a very significant, well, it should be at least, a very significant wetland. It has a whole bunch of coastline that is not developed, probably more coastline than a whole lot of other parts of Lake Ontario. It's the very, very western tip of Lake Ontario. It's a fish breeding area. It's a bird migratory resting area, a bird breeding area, and it was heavily impacted by carp. And this is what you see here. The carp have really ripped up the sediment, and the aquatic vegetation is no longer in place. And what was done roughly around this time was to put carp exclusion systems sort of where the highway is, and to work really, really hard to sort of sort the species, native and non-native. And then all kinds of efforts at replanting native vegetation and taking care of, as best they can, Phragmites and some of the other invasives that had taken over. Here's what it looks like today. It's looking a whole lot better, but water quality is still an absolute issue. And it's a beautiful place. There's all kinds of hiking trails. There's an arboretum, and it's kind of a very rich sort of wildlife area. And then Hamilton Harbor, very, very briefly, it's one of the, I forget how many there are, 30-ish areas of concern in the Great Lakes. It's also received an awful lot of sort of funding and attention to, they call these beneficial use impairments, right? Fish with tumors, contaminated sediment, water quality issues. And so one of these beneficial use impairments is eutrophication and undesirable algae. And this is largely a phosphorus concern. And so because there is government money available, this did provide an opportunity for us to apply for research funds to do water monitoring over the last while. So they have a target of around 60 ppb phosphorus in the harbor. And if you look at old data, it's quite something. I forget where it started, but they have halved the phosphorus, and then they halved it again. And there's one more half to do before they hit this target. And there's been an enormous investment in our sewage treatment plant to reduce phosphorus emissions into the harbor. And now the focus is going to have to be on the watersheds and some of the issues there. So there are agricultural sources, but most of the sources are urban in this area. So we have a sewage treatment plant, we have sewage overflow events, we have lateral cross connections, and we have a corrosion control program. And I'm going to spend a slide on each of those to give you a context of some of the challenges that this watershed faces. So I'll throw both of these up. Most of sort of the old parts of Hamilton, the downtown and sort of what we call Hamilton Mountain, near the escarpment. Those are areas that were developed, say, prior to the middle of the 1900s, before 1950, 1960. And the sewage infrastructure there is combined. So the houses are serviced with one pipe that collects stormwater, snowmelt, and also sewage. The white areas in the map, they have a separate sewage system. And so that's when, beginning in the 1960s, probably, they started to separate the sewage. Houses had, one pipe for picking up sewage and bringing it to the sewage treatment plant, a second pipe that picked up stormwater and delivered it to the nearest creek. Bunch of problems with both of these systems. The combined sewage, when you get a heavy rainfall event, the system is simply not able to keep up. And so our sewage treatment plant semi-regularly, especially this summer, I've been following the data. It's a little bit eye-opening. You get a heavy rainfall and they just simply need to allow overflow events to occur into Lake Ontario. And this was very, very frequent prior to the 1990s, but in the late 90s, early 2000s, they built 9 enormous combined sewage overflow tanks. And the system design is that as it rains heavy, if the sewage treatment plant can't keep up, they start diverting water into these tanks with the hope that the rain stops before the tanks are full. But once the tanks are full, they just have to open the taps and they allow combined sewage to flow into whatever body of water is nearby. And the sewage overflows still occur. I took this screenshot like 2 or 3 days ago. We had a night of heavy, heavy rain, and like pretty much all of the sewage overflow tanks were overflowing. These two, I'm going to have to walk. These two flow into the Chedoke Creek, and these ones over here flow into the Red Hill Creek, but they all ultimately end up either in Cootes Paradise directly or in Hamilton Harbor. And then once a week they log, and so you can get in and see how many hours the overflow event was and how much water was spilled, and the numbers are huge. Finally, one of these overflow tanks malfunctioned for 4 years, and no one knew. It's really quite striking. We're talking 24 billion liters of combined sewage over a four-year period was spilled into Chedoke Creek, and it got really, really bad in 2018. Like, people smelled it and started reporting problems. There's been an investigation from our province to our city since then, and it was just about a week ago that our city pled guilty, I think, to negligence and was fined $3 million for this. So this is what Cootes Paradise looked like. It basically was a sewage treatment plant in its own right. Those are lilies that were quickly dying. All right, so moving now to the separate system. And this again, when Darren and I started to hear these stories, we were, I think it's fair to say we were both kind of mystified how this happened. But in the 1960s, when the houses were built, many hundred of them were connected incorrectly. And we call these cross connections, where the sewage was directly deposited into local watersheds, and all the stormwater was sent. It was backwards. All the stormwater was sent to the sewage treatment plant. And this also was undetected for several decades. And it's hard to find them after the fact. And the city has had a program for quite a while now where they actively look for these houses and repair the cross connections. And this is also going to have a positive impact on the watershed. There's also partial cross connections where somebody without a permit puts a bathroom in the basement and they just find a pipe and pipe it in. And so the house is set up correctly, but there's one bathroom somewhere that's not piped in correctly. And then Hamilton's old. We have lots of lead pipes. And beginning in 2018, there was a corrosion control program put in place where around 1 part per million phosphorus is added to our drinking water to keep lead from solubilizing into the drinking water system. So this is a human health response, but it means that there's an awful lot of phosphorus being released into drinking water. The target is 1 to 2, but whenever we've measured it, it's close to 1. And this again, like Hamilton, they call this lost revenue, right? They are pumping water, purifying water, filtering water, delivering it to all the houses, and more than a quarter of it is lost in leaks along the way. And if you're just losing clean drinking water, it's not a huge concern. But if you're worried about phosphorus, then you're losing many tons of phosphorus into the environment in these leaks. And they've been looking for massive leaks and trying to repair them as well. All right, so that, I know it was quick, but it gives you a bit of a fairly detailed sort of overview of our watershed. And this is quite close to Redeemer. And so, Darren was really the one that sort of sparked this project he was teaching analytical chemistry and thought, we got to teach these analytical tests. Why not do it on an actual problem? And this was over 10 years ago now, but it's really snowballed for us in really, really good ways. So I'm going to talk about 10 years of water monitoring, and I don't think either one of us would have predicted where this project would go when it started. And then I'll wrap up again with some project outcomes. So we began monitoring in 2012, really focused on the Chedoke watershed with some pretty straightforward tests. And we've grown the number of sample sites, we've grown the number of tests, and we've added another watershed as well in this time. And since 2015, we've been able to fund this with external research funds, and we've hired students every summer to do work on this and keep this project going. And the city of Hamilton during this time, like I've mentioned some of these things, like we just, it was kind of providential, our timing, I guess, right? So when we started was the same time the city started actively looking for cross connections. And during the time we were monitoring was when that 4-year spill into Chedoke Creek was occurring. During this time, we began adding phosphorus to drinking water. And during this time, the city reported that they'd found some staggering leaks in their drinking water infrastructure and repaired them. And so, this is the whole point of monitoring, is to see what happens when improvements are made in systems, whether you can find an actual environmental benefit or not. So our sample sites scattered along the escarpment. There's a couple in the middle that aren't on this map, and then we have one right at the mouth of the Chedoke Creek where it's released into Cootes Paradise. And again, I just want to remind you of the sites. Right, you think about this watershed, how many challenges it has, and it is a broken watershed. Right, we live in a fallen world, and we see evidence of this in our Chedoke Creek. But it's also beautiful, and I keep thinking that there's opportunity for seeing this, somewhat restored. There's opportunities for improvement for sure. So we have typically in the fall with a class, we'll lead a class through a project, and in the summer we, with research students, you have a little more, fewer time constraints, right, where students can do more robust measurements and so on. But we've done bacterial assays with easy gel plates, so E. coli, total coliform. We've done a lot of chemical analysis, phosphate, total phosphorus, nitrate, chloride. Chloride mostly an interest because of road salts, but we also have some natural sources of chloride in the area too. And then we do biological oxygen demand. It's kind of an old test, which it's just one that speaks to people's knowledge about water treatment and so on. So we do that one as well. And we've gotten in recent years involved in microbial source tracking, because if you find E. coli in water, people can always argue with you that it might be birds or it might be animal sources. But microbial source tracking is a process. You can sample water, extract DNA, and basically do a PCR test on the microbes, the gut microbes that you find. And there's certain tests that will tell you whether those gut microbes were present in a dog, or they're present in a ruminant, or they're present in people. And this is kind of timely too, because we launched a biochemistry program, and this gives research opportunities for biochemistry students to work on this project as well. So we, it's always weird to interpret microbial source tracking results, but you're counting gene numbers, right? And so the more gene numbers per 100 mils of water, or gene counts, then the more of a particular microbe is present. And these results very closely follow our water monitoring data. If you look at the top, that is human gut bacteria, and Scenic Falls is our cleanest site and has the lowest counts. The ones in the middle that have all kinds of cross connection problems is where we find solid evidence of human sewage in there. And we've also worked on dog, and dog is a little bit everywhere. People, they take their dog for a walk and collect the poo and stuff it down the storm sewer grate or something like that because they think it all goes to the sewage treatment plant. But we find differences of different sites, different days, especially rain events, right? So you get a rain event and it just flushes all the pipes clean, and you find all the DNA in your water sample sites then. And if you take the data and just sort of normalize it for 100%, we see up to, 20, 30, 40% of the bacteria. Bacteroidetes is just a common gut, warm-blooded gut bacteria. Around 40% of it sometimes, as much as that, comes from human sources. And so, it's a pretty sizable proportion of the bacterial contamination is coming from sewage. All right, and now we have a really large data set of trends over time, all the water, the sample, I know it's small, all the sample sites across the top, orthophosphate, total phosphate, nitrate, BOD, chloride, and bacteria at the bottom. And we see these, and I'll highlight a few of them just to give you a sense of what we've observed. But the changes that we're seeing can be well correlated to the changes that the city has implemented in sort of infrastructure questions. So from 2012 to 2018, so this is the window of time that the city reported that they had found, I forget how many, like over 200 houses in the watershed that had been cross-connected. And so they had found them, dug up the front lawn, crossed the pipes over, redone all the landscaping, and then finding that, you see improvements in exactly what you expect. Less phosphorus, less nitrate, less bacteria in the watershed. And they were significant, right? Drops of half, drops of 2/3. Like we got really excited at this time. And if you look at sort of the vertical dashed line, that's 2018. Right, so some of these sample sites that had very, very poor water quality, they significantly improved over this time. And the city was we were happy to report this, and the city was quite excited at the efforts, the impact of the efforts they had made. What about since 2018, right? 2018 is when the city starts adding 1 part per million phosphorus to the drinking water, right? Got considerably worse. Again, almost all the gains that have been made were lost. In terms of phosphorus, E. coli was still improved, nitrate was still low, but you see this quick increase in phosphorus levels in the water again. And that, I think, is evidence of leaks of drinking water into the stormwater system. And in 2021, especially upstream of Cliffview Falls, upstream of Mount View Falls, they reported, and the numbers water main leaks that were millions of liters a day, right? And so when they fixed those, we start to see a decrease again in phosphorus. So we know what to do, right? We got to find the cross connections and fix them. We got to find the drinking water leaks and fix them, or replace the lead pipes and stop adding phosphorus to the drinking water, right? It's a longer term solution, but it would be a good one. And then finally, we have one sample site downstream of the CSO tank. And that site was always a mystery for us. If you take a look at phosphorus, look at the error bars. Like we would go sample over a summer, and some days it seemed kind of okay, and some days off the charts bad. And I think it was there'd be a minor drizzle, and this overflow tank was leaking all the sewage into Chedoke Creek. And I think now after the fact, we knew why that was. So our variation kind of went away after 2018, and very quickly BOD and bacteria counts improved. And so that shouldn't be surprising. If you stop adding sewage to creeks, the water quality improves. This summer, they're dredging a part of that creek to try and remediate, 4 years of sewage getting added. All right, project outcomes. I'm getting near the end, I think. Am I out of time already? Oh, I started late. Okay, can I have 2 slides quick?
Yes.
Okay, so really quickly, we've had student engagement, and we've made really neat relationships with people around Hamilton. So the Remedial Action Plan Office, the Hamilton Conservation Authority, the City of Hamilton we've been sharing data with, and we just feel more embedded in our place, right? We're interacting with city officials over this, and it's been really, really good for us and for our students to have these conversations as well. And we've had some really neat public information events where we've rented a hall and invited the public to learn the story of the Chedoke Creek, and that's been sort of a good experience for us as well. So we feel more connected with both the creek and the community as well. So sorry for going long, and thank you for your attention.
Thank you, Edward and Darren, and thank your students in this good work that you brought to us. I'll just contextualize this in place of a Q&A moment here. We can have Q&A. You can come up personally afterwards to keep us on time. I just contextualize this for you folks. What's going on here in Hamilton is being repeated in every municipality right across Canada. And I know it's going on somewhat in the United States as well. And this is a remarkable blessing in terms of the creation and the flourishing of people. As you see the detailed kind of work, and it's really wonderful to see undergraduate students getting this firsthand exposure to this kind of work. Just love it. So thank you very much again.